Welcome everybody to this webinar, which is part of the class Nonlinear Analysis of Structures, which is taught in the last year of the Master of Science program in Aerospace Engineering at Sapienza University of Rome. As part of this year program, we are very pleased to host this webinar on Autodesk MAYA, which is a powerful tool and software to create real-world animations of nonlinear structures while deforming or while moving in very fancy ways. And I'm very pleased to host this webinar within our class, which will be held by Mr. Federico Prete, an expert designer of aerospace structures, aerostructures in general, and an expert user of Autodesk MAYA. He has been working on a few projects within this class, so he's very well acquainted with our projects and our methods. So I'm very, again, pleased to welcome Mr. Federico Prete again to today's webinar. So Federico, now the floor is yours.
Okay, thank you. Hello, everybody. I introduce myself, and I'm Federico Prete. I got a Master of Science in Aerospace Engineering from Sapienza University. I was member of the Sapienza Fly team in 2011 in the edition of the Design, Build and Fly competition as head of design and production team. Our team got excellent scoring in the competition ranking in the top 10 ahead of the MIT team. Later, I was in charge of designing a highly maneuverable lightweight drone for monitoring and surveillance, which has been prototyped and ready for production.
Federico, would you like to show your slide on the presentation?
Yes. Okay. And currently, I am serving as production and plant manager at L.M.C. LAVORAZIONE MATERIALI COMPOSITI S.P.A. And in my current position, I handle the production of several composite aircraft parts, working for companies such as Alenia Armacchi, Bombardier, Bain, and etc. So let's talk about MAYA. Autodesk MAYA, commonly called MAYA, is a 3D computer graphic application currently owned and developed by Autodesk. It is used to create assets for interactive 3D applications, high-quality animations, and visual effects. It affords great freedom to customize the graphical interface and implement plugins, that is, tools written by third parties, not provided by the program. This is possible through Python, MEL, and C++ scripting languages. It produces images thanks to integrated and external rendering engines, such as Arnold, Mental Ray, and so on. An impressive feature of MAYA is the possibility of creating high-quality animations using analytical data provided by FE and multi-body dynamic simulation code, such as Adams, Nastran, etc. Let's talk about nodes. MAYA is built around nodes. An object, such as a sphere, is built from several nodes. A creation node that records the option that created the sphere, a transform node that records how the object is moved, rotated, and scaled, and a shape node that stores the position of the sphere's control points. We can see in the software now. I need to create the project, so I go on the File tab and set the project. I create a new folder. and set. We need to create the default workspace, and then we need to create all the subfolder of the project. So go on project window and accept. Now, if you go on into the folder, project workshop, you have all the folder you need. Now, activate the grid and create a Nurbs sphere. Okay. On the right, you can find the channel box and the attribute editor. If you go on the attribute editor, you can see the creation node that created the sphere, the shape node that stores the position of the sphere control points, and the transform node, where you can find the translation, the rotation, and the scaling of your object. You can change the parameters by clicking on one parameter, and then click the middle button mouse, and then you can move your sphere. Okay. You can select more parameters and again change your values. In Maya, you have the node as attributes, and an attribute is a position associated with the node that can hold a value or a connection to another node. Attributes control how a node works. For example, a transform node has attributes for the amount of rotation in X, Y, and Z. You can set attributes to control practically every aspect of your animation. There are many ways to set attributes in Maya. I show like the channel box or the attribute editor. In Maya, you can animate practically any attribute of the node and so you can have no limit on what you can animate. For example, I want to show you an example. I want to set a key on my sphere on the 0 point about the X translation. Click the right button, mouse button, and set key selected. Okay. In the time slider, the bar in the bottom, you have all the frame of your animation, and the red bar is our first key. I move my slider, and I change my value, moving my sphere, and again, right mouse button and set key selected. Rewind and run. Okay. You can animate everything. I show you another example. Go on the creation node, and on the first frame, set a key on the sections, for example. Set key. Move your frame and change your sections. Again, set key, and if you rewind, you can change your section while during the animation. Okay. For navigation, you can move by pressing Alt key on the keyboard and the left mouse button for rotation, the middle for pan, and the right mouse button for zoom in out. Okay, let's go on. How to use analytic all that? Usually, animations are made ad hoc by the animator without caring about the precision of the animation, but focusing on the final visual effect. However, if we aim at animations that are highly consistent with data obtained from simulations, we have a big trouble. Simulations have a lot of data, and the solution is writing scripts in Python language. In our example, we have about 6,000 values for animation. For our example, we want to create a high-quality animation of a wing bending under the effect of a follower tangential force applied to the wingtip, always orthogonal to the deformed beam midline over time. We also want the force to be increasing over time, as shown in the side picture. Here, you can see.
I can maybe say
yes.
a few words,
Yes.
Federico. So
Sure.
the students in nonlinear analysis saw the so-called nonlinear plane bending problem. This is a slide that will actually summarize the full 3D nonlinear problem. If we move to the next slide, you will see a sort of summary in the next slide of the plane problem when the beam is deforming only in one plane, as the example that we are going to solve, whereas this slide shows the full 3D, let's say, kinematic formulation where the beam can be subject to stretching, to flexural rotation about two axes, torsional rotation, and shearing, and so forth. So in the next slide, Federico, if you move to the next slide, okay, you have the summary of the beam problem, which represents a wing under a follower tangential load, where the equilibrium equation is simply given by this second order differential equation in theta, which is the flexural rotation as shown in the slide by Federico. The boundary conditions state that the shear force plus the applied tangential force have to be, of course, 0 for the balance, and the moment at the tip has to be 0, which is the second boundary condition. Then the kinematics are governed by these two differential equations, where you have the gradient of the longitudinal displacement equal to cosine theta minus 1, and the gradient of the vertical displacement v, which is equal to sine theta. Then you have boundary conditions on the kinematic variables u, v, and theta, and they are, of course, u equals 0, v equals 0, and theta 0 at the root. Okay, there is no displacement whatsoever at the root. So if we integrate all these boundary equations with the boundary conditions, we can get the full nonlinear problem, okay, under this quasi-statically increasing tangential follower force. This is what has been done, and the solution has been provided to Mr. Federico Prete for further processing, which is the object of actually is implementation and today's, let's say, illustration in all details. So thanks, Federico. Now you can control again the
thank you.
presentation. Thank you.
So now we need to go step by step for our animation example. First step, we need to construct the wing model. The second step, create join nodes. Then create animation nodes, set the environment and render, make a playblast, run the rendering, and at last compose the animation. So go on the first step. We need to choose the airfoil. For our example, we use an S.P.A 2412. Then we need to choose the wing geometry, and we use a simple geometry with constant chord and not twisted. Then set airfoil data files from TXT file to CSV files for the top and bottom of the airfoil. Then write a script to import airfoil data and create airfoil cards. And at last, construct the wing model. So let's try. We need to create a new scene. And I show you the file where we have our data. So open our data. Here we have the original file with on the sheet the time step. In the second column, we have the first displacement. On the second column, the second displacement about y. And on the third, the rotation. I have created the file, the three files for the displacement 1 and 2, and the rotation. Open one, and you see on the row the time step. On the column, the sections, all the sections. Now we must open the script editor. On the right, on the bottom right, open the script editor, and I have a script where I recall the data file from the airfoil top and bottom. I create two arrays. Then I set the data into the array. Define a function. Then I run the function for the top and bottom airfoil, set some parameters like the chord, the start, end. And then I create the top airfoil line and the bottom airfoil line. And at last, I create and move the airfoil. So run the script and close. And here we go. Okay. Now I want to extrude a wing along the positive x-axis, but an important, very important thing is that you need to close your line, because if I select the line and move one vertex, I have no connection. So I go on object mode. With the right mouse button, you can change the mode, the selection mode. So control vertex or object mode. Go on modeling interface, and then select the Curves tab and close your close your real line, but you need to check the box. If you select the name, the program applies the default setting, but you can change the setting by check the box. In this case, I use the default setting. Now we can again select the vertex and they are connected. Okay, this is a very important thing. Now, another thing is that if you open your profile, your Polar, okay, go on the data, the airfoil bottom as you need to have the same point for start and of the bottom, top and bottom of the profile. So if you see the top, you have 0, 0, 0, 1, 0, and 0, 0, and on the other 0, 0, and 1, 0. This is important. Now, select your profile and duplicate. For you can use the command on create on edit and duplicate, or the shortcut Ctrl+D. I use Ctrl+D. I have the second airfoil and move. Okay. I set the span here in the into the channel box. And now I have the two profiles. I show you some feature. You use the command on the left for selecting, for moving, rotating, and scaling. But you can use the Q and R for rotation. I'm sorry. File by pressing Shift and go on surfaces and loft box. The sections are 100. Now I want to create Nurbs. You can create polygons, but I want to show how to change the Nurbs into convert the Nurbs into a polygons. You have your wing. Nurbs are non-uniform basis splines. It is a bit complex to use. I prefer Polymesh because you can modify easier your model, and you can create the cap for the wing, for example. The black on the wing, you can see the black on the wing. This is because of the normals. So if you go on display and then Nurbs and normal shaded mode, you can see that they are inside. Okay. I want to reverse, and I go on surfaces and reverse direction. Now the black is into the middle, and uncheck the normals display again. Okay. If you want to see the gray on the wing inside, you can change the lighting in the bar, in the viewport menu. Go on lighting and two-sided lighting. Okay. Now we need to convert the Nurbs into a Polymesh. So select the wing, go on modify, and convert Nurbs to polygons. Check the box for the setting, and I want to want the same control points. So check the select the slit, and you have a Polymesh. The icon of a Nurbs is different from the Polymesh. I want to hide all what I don't need, and click Ctrl+H. And now we have our Polymesh. We can rename wing model. Okay. Now I want to preserve the span, so I need to extrude a bit of the wing. Right mouse button and go on edge. For the selection, I show you some feature. You can select the edge or a loop, an edge loop. Click by clicking the first, press Shift and double click on the nearest, or range the edges between two edges. Select the first and the last and double click. Okay. This is for vertex. And for the faces, the same. Okay. And you can do everything on your model. Also, you can rotate and scale. Okay. Now I select the edge loop. And then I use the extrude mode, extrude command by clicking Ctrl+E. Then I need to change the pivot into the middle. And then I extrude my wing. The same on the other side. Select one second, Ctrl+E, pivot into the middle, and then extrude. Now select the edge loops and go on Edit Mesh, Merge to Center. Now you need to move this vertex and align to the others. You can check, you can click the snap or use the shortcut by pressing V. Select the vertex and then W, press V and move. Okay, the same on the other side. So repeat. Select, edit mesh, merge to center, and move and move. Now go into the edge mode. I want to smooth the edge.
Federico,
so
did you define the center?
Sorry, use the bevel.
Federico, can you hear me? Did you define the center? It doesn't.
Higher. One, two. Okay, and this is okay. And now I want to show you another thing. If you use an Nurbs, you have a smooth profile, but with the Polymesh, the line are strength. So if I change the view by pressing bar and then going on the side X, again pressing bar space, you can see that the line are strength. So I want to change this problem. This is a problem for us. I can go on Attribute Editor, then I go on the Shape node and the Smooth Mesh tab. And I use the Smooth Mesh preview, the display cage plus Smooth Mesh or Smooth Mesh. Here you can see the cage around the wing. You can move between this visualization by pressing 1, 2, or 3. And now I have my return to the perspective view, and my wing is perfect for us. Okay. At last, if you are satisfied with your model, you can delete all the history, because Maya records all your command. You can see the command in the channel box here. You have the extrude, tessellate, the merge, all the command. If you select, go on edit, delete by type, history, you can delete all the commands. And now your wing, okay? So go on the next step. Create joint nodes. Joints work in Maya like a skeleton for a model animation. This process is called rigging. So you need to set animation data files. For each degree of freedom, you have to create a CSV file with time set values on the row and variable at each section on the columns. The example used normalized values. Write a script for joints creation, one for each wing section of the simulation data, and at last run the joint script. You have seen the file, the file are the bin R3, S1, S2. Open the editor script and change the script. Again, here I set some parameters, the span, the nodes 101, the file I recall, the 3 arrays I need. Then I define a function for set the data into the arrays. Then I run the 3 function for the 3 displacement, set the coordinates, and at last I create the center nodes of the beam. So execute and close. Now I can't see the nodes because of the wing. So I want to hide the wing, but I create a layer here in the right button. Create layer from selected, change name, wing. Okay. And here you can change the visualization. Templated, and referenced. In this way, you can't select the wing for misclicking. I can hide here, and I can see the nodes. Here I have all the nodes I created. Again, I create a layer for the nodes. Okay. And okay, now I can see the nodes. And so we can also group some objects into the outliner by pressing Ctrl+G. Okay. So go on the next step. Create animation nodes. We need to write a script for animation nodes creation. You need an animation node for each degree of freedom of the analytical simulation, and this group of nodes for each section. For example, we need in our animation 303 animation nodes, for the 3 degrees of freedom. And then run the animation node script, then select all nodes and the wing object at last, and use the command bind skin. So the wing is like a skin for the skeleton, and so we can see into the program. Now I go on into the editor script and create. Here we have some parameters: the nodes, a time factor, the beam length, an amplification factor if you want to reduce or increase the displacement of the wing, the file that we recall, the arrays that I create. Then I define another function for setting the data into the arrays. I run my functions for the 3 files, set the starting coordinates, and then I create the animation curves here. I set the animation curve keyframes, and then I connect the animation curve to the joint node. This for the first displacement, the second displacement, and the third, the rotation. And at last, I connect the animation curve to the joint nodes. So execute and close. Now we can try to run our animation. Okay, but the wing doesn't move. Here into the time slicer, you can see all the key of our animation. And we need to skin the wing by selecting all the nodes and at last our model. Then go into the rigging interface here on the top left. Select the skin tab and then bind skin check box. Here, set max influences to for good results, but you can try the setting for best results, and then bind skin. Now run again, and the wing move with the joints. Now I want to oscillate the wing, I can go in the bottom right on the set animation setting here and set the playback to oscillate. We can set once, oscillate, and continuous. Set on the oscillate and then move your time slicer or set to the last frame 100 and 100. The first is 0 and 0. Rewind and run. Okay. Now we need another important thing for our render. We need to set environment and renderer. The integrated Arnold renderer is used for photorealistic images and animations. We need to create light source, in our example, a directional light, and then create a background and put it on a layer, set layer to reference it, assign materials to wing and background, then set material option using hypershade, use the IPR, that is interactive photorealistic rendering feature for a real-time rendering, and set the render setting into the rendering the window, the setting window. And at last, we need to choose a best view for our final animation. So let's try the software. Okay. We need to create a light. Go on create light and directional light. You can't see because you need to scale it. So select the X, Y, Z and middle mouse button and drag. And now you can see. You don't care where you put the light because it's a beam of rays. But you can rotate the light for a better view. Now we need to create the background. I create a Polymesh square, and I set the subdivision into the channel box, the A subdivision. Okay, I can scale. Okay, now I show you a very useful command. Go on one of these on the move command and double click with left mouse button. Go on soft selection and here activate the soft selection. Here you can change the fall off radius. Now I show you how it works. I select the vertex, the first and the other side, okay, by pressing Shift, and I increase the radius. The yellow move with my arm, the black doesn't move. So you can create a trend for your selection. And this is very useful. Here you have some curve presets. Now, uncheck soft select for the future. Now go again on object mode, scale a little bit, move down, and here we need to fit. Okay. Now I can misclick, so I need to create a new layer, select the background. We change the name. Go on layers, create layer from selected, and change the name. Okay. And now we can reference. So we can select now. Okay, this is very useful. You must use the layers. Now we need to assign material. So we start by we change our visualization. Okay, select the wing. Right mouse button. Go on assign new materials. Then Arnold shader. Yeah, I use AI standard surface. I change I want to see the material. The material I can go on display in the outliner and check assigned material. And here I have my material, new material. I change the name. Standard wing material. Here you have presets. I want brushed metal. Don't worry if you see the black. Okay. Now I need to see how it looks. So I go on into the hypershade by clicking this icon, this sphere icon, or go into Windows tab, then go on rendering editors, and then hypershade. Here you have all your material. In our case, we have our wing material. I can change, for example, the metalness. I reduce the metalness, and it is in real time rendering. So I reduce a bit, maybe 0.5. I want increase the roughness. And you can change a lot of parameters. You can try yourself. So I close my hypershade. And now I assign a material to my background. And I can select now, but I select here in the outliner, or I can go into the channel box layer, click on the background layer, right button mouse, select objects. Okay, and select objects. Then again, right, assign new material, Arnold shader, AI standard surface. And here I have my material. Okay. I use velvet. I change the color, maybe lighter. I change the sheen. And now we have our materials. Now, we can use the IPR for fast rendering in real time. Here, I can set my scene. I need more light, so I can select a part for fast rendering, go on the directional light, select the directional light, and increase the intensity. We can try 3 or maybe 5. Okay. Then again, we can see we can move the view for a best results. Now I stop my IPR and close. I select into the menu, viewport menu, the field gate for the visualization of the animation, and then the resolution gate. So I have my final size. Then I need to set the render. So go on the icon with the gear in the top here and set some parameters. On the common tab, set the file output. I usually use PNG. Then I need to change this because it's only single frame, but I want all the frames. So I change the animation extension, frame extension. I use this. Then I need to set the start frame 0 and end frame 100. You can use keep existing frames if you want to start and stop more times your rendering. So the software keeps existing frames. Then you need to set the image size. I use HD 1080 and pass on the Arnold renderer setting. Here you have the sampling. The main is camera AA. Is a super sampling that control over the number of rays per pixel that will be traced from the camera. The higher the number of simples, the better the anti-aliasing quality and the longer the render times. The exact number of rays per pixel is the square of this value. So, for example, a camera AA simples value of 3 means 9 pixel simples. In practice, you may consider using a value of 4 for medium quality, 8 for high quality, and rarely 16 for super high quality. This control acts as a global multiplier of all the different rays, multiplying the number of diffuse and specular rays. Motion blur and depth of field quality can only be improved by increasing camera AA simples. The other setting controls the number of rays fired by diffuse light, specular light, transmission light for transparent materials, and subscattering surface. For our example, I set 3 on the camera AA and 4 for the diffuse, 2 for specular, and 1 for transmission. Another important setting are the ray depth. So, ray depth allows you to configure settings that limit the ray recursion based on ray type. Higher values will increase render times. Total setting specifies the total maximum recursion depth of any ray in the scene. Diffuse defines the maximum ray diffuse depth bounces. Specular defines the maximum number of times a ray can be specularly reflected. And transmission set the maximum number of times a ray can be refracted. Volume is the parameter that sets the number of multiple scattering bounces within a volume. And at last, transparency depth is the number of allowed transparency hits. So with zero set, if we set 0, objects will be treated as opaque. Okay, but I use the default setting, but you can try different setting for your. And I close now. Okay, we have our environment rendering setting. So let's go on the next step. We need to set the camera view. Okay, I chose my view by running the animation. Don't worry if you don't see the shadow in this visualization. Okay. Now, go on panels. I'm sorry, on view, and create camera from view. And here into the outliner, I have my new camera, and I change the name to custom camera. Then I need to lock the camera, so I can't navigate and move my model. I can change by panels tab perspective, and again I can return on perspective, so I can move again. Okay. Now I go on the next step. Make a playblast. If you want to create a fast video, you can make a playblast. Playblast is an animated video without rendering. You see what the viewport shows. So let's try. I want to show you, I select a wing, for example. Go on play black, then playblast. You need to go on into the animation, because if you change the interface, you don't find the playblast. Go on animation, playback, and playblast square. Time range is time slider, it's okay. Format is QuickTime, and it's good. The encoding uses H264. Here you can reduce the quality. You can change the scale and set a name. Playblast example. And then click Playblast. And you create a video with viewport visualization. So I want to show you, go on your project folder, project workshop, movies, and here we have our example. Now, go on the next step, the most important step. Run the rendering. If you are satisfied with the outcome, you can go on the rendering menu and start a render sequence. So, well, let's try. Move your. We have our custom camera. Okay. Go on menu tab, render. Go on rendering interface at first. Then go on render tab, and then render sequence, and check the box. Here you can render all render enabled cameras, and I show you where you find the enabled cameras. Here in the setting, we can find on common tab the renderable cameras. You can change the renderable cameras or create new cameras. Okay. Return on the render sequence. We want to render the custom camera. You can change the name and the location of your output, and render sequence and close. And Maya starts the rendering process. Frame by frame, it is a bit long because we have 100 frames. So I can stop the rendering just pressing S key and close. I can show you the first partial render into the project folder, images, custom camera, and here I have my partial frame. I show you the same just done images, and here I have all the frames rendered. And we can go on the next step. The composition of the animation. Maya just create a frame sequence. So you need a composition application like Adobe After Effects. So open After Effects, import the frame sequence, and remember to check the PNG sequence. Create a new composition, set the same parameters of your frames, drag the sequence into the composition, copy multiply sequence if you want for oscillation, and reverse some of them. Now I'll show you. Make a pre-render, set the output module setting, and at last choose the name and select render. Now I open Adobe After Effects. I need to check the detail of my file. Go on Properties, Detail, and check your size. Okay, and the size of your frame, but also the FPS, the frame per second, on the Maya viewport here in the bottom right. That is 24. You can change when before of animation. Now, go on After Effects and click File tab, then import multiple files. Go on the images folder and select the first frame, 0 frame. Then check the PNG sequence and open, and then done. Now you need to create a composition. Select Composition tab, New Composition. Set your size. In our case now is the same. You can change the setting and check the frame rate, 24. Set the duration and select OK. Now into the composition, now you need to drag your footage into the composition. Then I need to duplicate this composition, this sequence by selecting and pressing Ctrl+C, and then unselect and Ctrl+V. Again, unselect, Ctrl+V. And I need to move, but I need to snap. You can snap by pressing Shift, holding Shift, and then move. The same for the third sequence, and you can move your slicer, but we have no oscillation. So we need to reverse this second sequence. Select it, go on Layer, Time, and then Time Reverse Layer. So now we have our wing oscillating. Now we need to make a pre-render, going on Composition, and then pre-render. Here on the bottom, we have our pre-render. We need to set the output module. Choose the format. I use H264, and here you can change the format options. Increasing these values will increase your file size, the output file size. I leave these values. You can also check the audio output if you have a track into your in the composition, but we don't need now. And press OK. Go on the output name and change it. And see. And at last, render. Select render. It is a fast process. With the composition, with this application, you can do a post-processing of your animation if you need. So we have our animation in the folder movies workshop example, and here we have my animation. Right now, go on here, the same animation. your video is ready. The same animation here for a complex model. Here is a clay blast with the same node movement and a complex model with a rendered setting. This is a rendered model animation of a complex wing. It is at low quality, but it took about 6 hours of rendering. Now, if you, as a scene, I put an arrow attached on the wing, and I want to show you how you can do the same. Okay. Go on the software and check this. Okay. Change the camera and check the gate. Hide the you can hide by pressing Ctrl+H. Now I create a polygon. I change the subdivision into the channel box. One and here. Okay. Now I need to create an arrow, so I switch to face mode and I need to select the phase loop and the bottom. You can change it now. The navigation is quite good, but you can modify the scene sensitivity by going on view in the viewport menu, bar menu, and then camera tools, tumble tool, checkbox, and you can tumble on the object. So I can move around the object, and then I can decrease the sensitivity, so I can move better. Okay. Now I need to select the bottom faces, and then I extrude with Ctrl+E. I center the pivot, and then I scale inside. Now I need to change again the mode to edge. Select the first shift plus the second. Then okay. And now I can say no, I only need to scale. I don't need to extrude. Okay. Then select the object and scale again a bit, and move our arrow. Okay. Now I show you if I add the nodes, what happened. I rename my arrow. Then select by middle mouse button and drag on the node. I need to open my node. The last node is the 101. Okay. So select middle mouse button and drag. Okay. Now you need to release on the node, not between. Now the arrow is the arrow is a child of the node. So if I hide the nodes, the arrow now is on the node layer. Okay. Let's try the animation. And the arrow follow the wind. Here we go. Go on. I want to go into deep. I will show you the node editor. The node editor presents an editable schematic of the dependency graph, displaying nodes and the connection between the attributes. It allows you to view, modify, and create new node connections. Go on the program and okay. Open Windows tab and then Node Editor, and you have Node Select. So if you select the wing model and then go again into the Node Editor, you can click on this icon to show the wing node and the input and output nodes. If you select and then click the first, you only have the input nodes, and for the last, you have only the output nodes. You can change the visualization of a node by pressing this icon. This is the simple visualization. This is the connection connected visualization, and this is the full visualization that show you all the input output of the nodes. And here you can see all the nodes. If I select a node, for example, and try again, I see the animation node for the displacement about X, Y, and the rotation around Z. I see the node layer, the skin cluster, and the wing model shape. Okay. And here you had all what I shown on the node editor for the animation example. This is the node animation for 3 nodes. All are connected into the skin cluster and then into the wing shape. Another important editor is the graph editor. The graph editor is a graphical representation of interpolation between animation keys that you can modify. To see your animated nodes, select all nodes and open graph editor. Here you can select nodes as you want, and you can see all the trend of your animation. So I show you into the program. And select the nodes. Then go on Windows. And animation editors and graph editor. There we go. Here is the animation key for all our nodes. You can also select only one node. See the translate, about X, the red line. The green line is for the Y, and the rotate Z for the blue line. But I show you that you can also change the tangent by selecting all the nodes. Okay. Then go on tangents. The default is auto, but I prefer the spline mode, and I show you that spline is better. Or you can use linear or straight line, straight animation line, or clamped, stacked, and flat. Or key, the key as flat tangent. Of course, you need to change this value, this setting before the rendering. Okay. And now we can close and go on. Here, all the nodes of our wing animation example. And now I'll show you some rendering. This is a frame rendering of a complex, of a compact vibration absorber for thin wings I worked on. This is at high quality because it is only a frame. Here, another image, and here an animation of the object. Now I show you another animation. This is the animation of the Yangtze bridge in China I worked on. The bridge has a series of vibration absorbers for flutter control. It takes several weeks of work and about 4 days of rendering at not so high quality. With more time, we can have a better result. Here you can see that I did the material of the deck transparent. I used the key for this. So I changed the value of transparency for during the animation. Here, an animation of a UAV I designed for the Air Square startup. And here, an example of mechanical animation to show you what you can do with Maya. Thank you. Any questions?
Thank you, Federico. Can you actually hear our audio?
Yes.
Okay, because we are trying to ask you questions during the
presentation. But I didn't hear.
Yeah, exactly. For some reason you couldn't. There were a few questions. I would like to say that the level of realism of
I can't see. I can't hear.
Can you hear now? Can you hear, Federico?
I can't hear.
Okay, he has an audio. He has an audio issue, so probably he turned off the speaker or something happened using several layers or software. I don't know what really happened. I wanted to comment while he tries maybe to turn on the speaker, that the level of realism that you can achieve with the animations is striking, as you saw in the wing, in the bridge problem under flutter and flutter control, as you also saw in the very last example with the mechanisms that were rotating. It seemed exactly like a real machine that was actually working. Of course, you also noticed that everything is run by a model. So the model that is actually...
I didn't hear.
Yeah. So can you...
Can you repeat?
Can you hear now, Federico?
Yes, now I can hear.
Okay, so you turned on. Okay, Federico, I wanted to say that the level of realism of your animations, and as you also mentioned, this is not the highest quality that you can achieve anyway, is still astonishing, because some of these animations seem to be the real object, you know, moving and rotating machinery and so on, or the bridge fluttering. It's impressive because it also allows maybe to learn more about the physics, the outcome of the model, which is exactly also the idea behind animations, is to better show and to better, let's say, appreciate, okay, the mechanics, the motion, and so forth. It was a very comprehensive tour, Federico. I'm very impressed by the fact that you could manage all of this in 1 hour and a half in a very clear way. There were a few questions. I had one question while you were creating the wing model. At some point, you had to close the two end sections, right? The root and the tip. And so you were using a center point that I wanted to ask you about. Is that the center point which actually belongs to the line of all the nodes? So to speak, the center line of our model, or it was actually preset by the program?
It is preset by the program, but you can move.
You can move. Okay.
Yes, you can move to the center of the center line of the model. Okay.
One more question is about the Nurbs versus the Polymesh. So do you need to start with Nurbs and then transform it to Polymesh, or you can right away start off with Polymesh?
I can start with Polymesh. I did the Nurbs and then Polymesh to show how can convert the Nurbs to Polymesh. But if you set Nurbs into the loft command, you can create Polymesh.
Okay, thanks, Federico. I wanted also to mention a word of caution. You saw that we were using a nonlinear, straightforward nonlinear model for the beam extreme bending, right? It seemed to be, especially with the more realistic wing model, where we also saw the ribs and the longerons and so forth. We saw a sort of foldable wing which was folding onto itself, and I believe that caught your attention. That of course, you know, this is a sort of simulation of an extreme event, because if you think about the fibers belonging to the airfoil on the bottom and the lower part, they are subject to an extreme compression and stretching. So that applies to a highly deformable, let's say, material. So it's really pushing, you know,
it's only a simulation.
It's a simulation. It's pushing the model to its limit. But
yes.
if we had a super compliant material, we could actually really see it, okay?
Yes.
Because that model is accurately describing exactly what happens in an extreme bending. Of course, there are other effects which are not exactly captured by that model, because when you start stretching or compressing fibers into finite, okay, deformations, then the material behavior cannot exactly be described by linear constitutive law, which is what we used, okay? When you start compressing fibers extremely, you need material that becomes harder and harder, right? So it cannot be linear. So there are a number of limitations, but that's the model. The focus here is on how we can really animate these structures to the point that we exactly see all the details while it's on the fly. So we had a question by Guy.
I want to see a thing about that. You can, in our case, we had only the nodes in the center line, but if we have the nodes on the surface in more points of the wing, we can create an animation, a simulation, a better simulation of the wing.
Absolutely, Federico, and I want to mention.
I can hear.
Yes, I want to mention that one of the projects for this year could be to animate a 3D beam.
I can't.
A project could be to animate a 3D beam problem. So it can be a wing. Okay, it can be a wing deforming in space. So it can be a beam twisting and bending and maybe shearing and so forth. So that could be a project. But I want to say that Simone was asking about Maya capability to perform real-time ray tracing. Can you hear Federico? Okay, he has again speaker problems. So can you, Pranat, unmute Simone? Simone.
Yeah, I did. He's in.
Okay. Okay. So Simone, please ask your questions. Let's see if Federico can get back.
Yes. I have asked if in Maya we can perform real-time ray tracing. So I noticed that we work in a deferred environment, not real-time for the render. Okay, so I ask you if there is an environment in where we can perform something in real time, like ray tracing, for example.
Okay, you want to do a simulation in real time?
Yeah.
You can't, but you can create your equation with Python, and then set the animation with your equation.
Okay. And what about, for example,
without importing your data? You want, no?
Yeah. And also I have another question. It's for physics. So we have seen some simulation in which the data was from a calculus we made, and so we show these results. But we can have the possibility to have real-time environments for the physics, in which, for example, we can change the load on fly, and so we can observe the new results.
Okay. Maya need a lot of time to render the animation. So it's a bit difficult to have a real-time animation. But you can set your parameters like the load into an attribute. You can create an attribute with your values.
Okay. Okay, thanks. And also, last question for when we have some application that requires a large amount of computational demand. So there is in Maya or by Autodesk a cloud-based computational approach.
Maya is a physics interface. To you can simulate some physics problems.
Okay.
I didn't show because it is a bit complex to show in a webinar or an hour, half an hour.
Okay. Yes. Yes. It's only for
Okay.
information. Okay. Thank you.
You're welcome.
So Federico, along the same line, so can you actually implement a model that will run computation, or you still need to provide data for the animation? So does it have a computational engine, you know, maybe written in C++ or some other software, or you simply need to provide each time new data sets?
Maya has an interface for physics,
okay,
for physics problems, and but you can't. Is like a wizard.
Okay.
For you can't change the equation, but you can use the script editor in order to create your equation in Python, and then use it on the software.
So you can, for example, call MATLAB to run the computation and then use the script to load the data right away. Okay.
Yes.
So in that case, this could be an approach to what was mentioned. If, for example, you change the loads, then you can change the load in a range, compute the solution again, reload the data set, and run a series of these maybe simulations.
Yes.
But still, the impression I got is that there are so many steps to get to the final, let's say, output for the animation, that probably you cannot really do this in a loop.
I can't hear again.
Okay, yes, again, the audio issue. I believe that if you have more questions, we can try to reconnect with Federico. Otherwise, since we are exactly on time, I would invite you to write up your questions in our channel, okay, in our Teams channel, so that I can forward your questions to Federico, and maybe he can also help us with projects. I mentioned right before,
I'm sorry, but
one of the projects could be, implementing the 3D wing problem as we move forward, and then try to see animations under different load conditions. And that would be, I believe, also an interesting project to animate.
Now I
okay, you got back with your audio. So this is part of, the challenges with using several tools. I was just mentioning, Federico, that one of the projects where you may also assist is to go with a full implementation of a 3D wing model, where we apply, for example, the same follower load, but it can be eccentric, so such that it doesn't go through the center, elastic center of the airfoil. In that case, we have, shear, bending, and twisting.
Yes.
And so we can realize all these complex shapes in 3D space. and that has not been done so far. So it's a new possible project. I want to thank all the students. I believe that this audio problem, of course, refrained some of them from asking questions, but I believe it was very well delivered, Federico, very effective, and I want to thank you again for showing all the capabilities and know-how that you have built over the years, you know, in using Maya. I believe this is quite rare as an academic program, okay, to show, let's say, this learning process to you. So I hope you will exploit, okay, this opportunity to the best. So best wishes to everybody. Thanks to also Pranat for hosting the meeting and the webinar. And let's now reconvene for the next workshops. We will have a series. We will have next week workshops on Astra and Sol 400, where we'll simulate interesting nonlinear problems. And then we will have workshops, you know, using atoms. And now again, some of the projects can be based on Nastran and Adams. And then if you are so interested in pushing the limits of animations, we could then use Maya for the animation of these models, okay? So thanks everybody, and have a good evening. We will catch up in the next workshop. Bye.
Thanks everybody.
Yeah, thanks to all of you.
Thank
and
you.
Let's stop the recording here. Thank you.